What are the forces that will mg will act? Normal reaction n1, and there's no friction. It's in equilibrium, so therefore we can write it as the force that is equal to say you get wide varieties of paper. I think in one of the year, no, the rotation mechanics, two papers, no, it will be like a 60 marks and P2. P2 is also, it was around 54 marks. The maximum year was 8. The maximum year was around 13. The questions were of that kind. It doesn't mean the student don't know anything. The level of questions are something three-dimensional one. You should imagine diagram, then you have to get, and the language also a little bit, technical language, no? The maximum, this was the 21 marks for the highest for this in our institution. It can happen. It doesn't mean that you don't know anything. Hmm? So all the basic fundamentals, you know it, that is sufficient for the exam. The level of paper may come in such a way that where you may get single digit. It doesn't matter, I feel. It can happen. It all depends on paper also, the level of paper. Okay, for a translational equilibrium, net force along x-axis should be 0. P minus N2 should be equal to 0. Along y-axis, N1 then I want the torque about point B. So let me define net torque. As it is equilibrium, we can define torque about any point. Let me define torque about point B, that one. So this should be the net torque. This should be equal to, what will write equation? So this should be P into L cos theta, capital L, P into L cos theta plus N2 into L sin theta plus mg into L by 2 cos theta. So the net torque is 0 for rotational equilibrium. So L will get eliminated. So P cos theta plus N2 sin theta minus mg by 2 cos theta. N1 should be equal to, this is N1. I'll change it. What is N1? N1 is in fact equal to mg.
The directions you took different.
Let me do it. This is anti-clockwise. N1 clockwise, no? Oh. Okay, let's take care of it. mg2 plus mg sin theta by cos theta. So mg2, let me take it outside.
About which point you're taking torque?
About point B, no?
Point B, then torque by the force P and torque due to weight will be in the same direction also.
Wait. About B, no? Torque due to P and mg will be in same sense.
Normal contact should balance it.
Okay, this one. Yeah, this one. P. Okay, torque due to mg. I'm unable to, I think, try to, this is mg. Torque due to this will be, it'll be in this sense, no?
Yes, sir.
Okay, all of you just make notice, that this will be, the torque about point B due to mg will be in this sense. Because see, just like R bar, this is F. So it will be in this sense. Torque due to N1 will be, this is N1, this is R bar. So it will be in this sense. Torque due to this force P bar and this one. So it will be in this sense. So torque due to mg and P will be one sense, anti-clockwise. Due to N1, it will be clockwise. Then, okay, based on that, This will be positive. I'll take it.
N1L
Algebra.
cos theta, sir,
N1L cos theta, no?
and P1L sin theta.
PL sin theta.
Oh, this is sine theta. I'll rewrite this one. So net torque should be 0. So 0 is equal to PLL get cancelled. So P sine theta minus N1 cos theta plus mg by 2 cos theta. So this P is equal to N1 is equal to mg. One more step, I'll write. Mg by 2 cos theta. Okay, now slowly, you only try to set out few things like instead of this external force, no, can I bring a spring? Especially in matchings, no, the teachers will be interested to make you analyze. We'll have a rod. So can I bring one spring here? Find the elongation in the spring at equilibrium. Or compression in the spring at equilibrium. The P equal to should be Kx naught. The P should be equal to Kx naught. So the things can be like this. So many different things will be just messed up here. So I suggest you instead of external force, any other thing. So you can bring a like I can connect one string here. I can connect one spring, one string here. What will happen to string? String will be definitely will be loose. When a spring will be elongated, especially in matchings. So we do go for some very lengthy numerical, but small ideas based. So that P should be equal to Kx naught. No. Similarly, so if you take the just like we are trying to. So if there's the same rod, I will inch about this. Then I'll connect a spring. Very random, huh? So like this and all. So will it execute SHM? The spring remains horizontal. Yes, in fact, it will be SHM. All these are interrelated. In fact, it should not be free. It should be injured, that one. So slowly you displace, no, that the rod is going to. I'll remove the rod. I'll just show it one. There's a thing there, no? So now you see this particular rod. So in fact, I think length will not increase, no. So it should be like this. Huh? Then this is SHM. It cannot be like this. Huh? Length of the rod will increase. I think we'll be in a wrong position here. So slightly it should come in this way. So it is like some sort of an angular SHM, compound pendulum it will become rather than something. So you slightly displace, the weight mg will act. then the spring force spring will not remain horizontal, little bit change. Some mathematics may be brought, but it will be SHM. In exams, they don't want to trouble mathematics. They just say that uh, like a, if it is rod is displayed about its range and release, will it execute SHM? Yes, it will be. It can be like this, no? But it cannot be like this. Huh? This is not possible. Am I right? Like this, the rod length of the rod, how will it change? Not possible, no? Then the length of the rod cannot change. So therefore, it has to be oscillation. If the the rod has to rotate in a plane, then it will be SHM. So like this, they may trouble you. They don't want to ask you anything very big. Simple idea based. So here it will be like this. It will be SHM. So especially you see the advanced papers, no, the matchings, no, rather than asking some derivation type, they want you to analyze here. So one situation, if it is connected, no, so just be aware of these things. See, in exams, we can't, you see, again, what I suggest, like take different numericals, try to change some conditions. That's what happens in most of the math the following. There's one very popular way of asking some rigid body mechanics questions in matching. It'll be very easy for examiner to ask from rigid body mechanics in matching than any other concept. Now, this is, if you see previous problem, what is the state of this rod? Shall I say rest? Rest is a word. No, this equilibrium torque, equilibrium, rotation equilibrium can be defined only when the body is at rest, or body can be in motion also can be defined equilibrium. Yes, in fact. This is a very rare problem where we are going to discuss the equilibrium concept where the body is moving with a constant speed. Even it can also happen that body is rotating, then we can discuss the equilibrium.